man's best friend. Good security. A great warning device, among other things. Of course, everything has its place. And on a John Deere Titan Series combine in the field, well, there are more practical sentries. However, the point is the same. Warning devices are there to get the operator's attention, to make him sit up and take notice that something's not right. And those devices must be loud enough and bright enough to get his attention. Wrapped inside the sound guard-styled cab of the modern Titan combine, the operator simply might not hear what goes wrong with his machine. So there must be a device such as this, the low shaft speed monitor system on the Titan Series combines. This monitor triggers a warning that keeps a minor malfunction from becoming a major repair. As the name implies, the monitor system warns when certain rotating shafts within the combine begin turning too slowly. The monitor covers 5 such shafts. These are the conveyor auger drive shaft and the tailings elevator upper auger. A question: why not have a monitor for the lower auger too? Answer: because the two have a common drive. So whatever goes wrong will show up on the monitored upper auger. Next is the clean grain elevator lower auger. Once again, both augers have a common drive, so we only need a monitor on one of the shafts. Fourth, the straw walker crankshafts. And finally, the straw chopper rotor. You should know that when these various drives start going too slowly, when they set off the warning buzzer, they don't do so in any particular pattern. All 5 have been known to go at once. Or 2 or 3 could start running too slowly at a time. Or 1 at a time could fail. What causes these various drives to turn too slowly? There are various reasons. The most common being slippage of a drive belt or a crop overload. In addition, the straw walker may have suffered a mechanical malfunction, like a slip clutch failure. And the tailings elevator augers may jam from excessive tailings or some large foreign object. However, these are examples of what causes the monitor to sound its warning. This program is concerned with how the system works, and for that, you need to know the monitor system's main components: the monitor control box, the sensing device, and the wiring that connects the two. We'll begin with the control box and what you do with this. And the answer is simple: nothing. Not a thing. The control box itself is never to be opened, not for any reason. Here's why. John Deere does not manufacture this component. It comes to us from an outside supplier, and to open the box would void your customer's warranty. To make doubly sure that no one opens the box, the manufacturer has sealed the box cover screws. Break that seal, and there goes the warranty. Know that the control box contains the wiring and electronics that read the sensor and activate the warning. And that's about all you need to know about it. Except that it's also a pretty reliable piece of equipment. Our statistics show that whenever LSSM control boxes have been returned on suspicion of being faulty, in the vast majority of the cases, the box was found not to be defective. Something else was found to be wrong: a faulty electrical connection, or indeed, a mechanical failure. Let's now look at the sensing device itself, composed of a switch assembly and a plastic clamp ring, which contains a magnet. The plastic ring with its magnet is clamped around one of the bearing locking collars on each of the 5 shafts, so it rotates with the shaft. The other half of the sensing device, the switch assembly, contains a reed switch. This switch remains open until the rotating magnet passes nearby and pulls it closed. This assembly comes sealed and is normally not to be opened, as we have done for this illustration. A 47 to 52 ohm resistor is in series with the switch. The control box applies a continuous 5-volt potential to the connector. Each time the magnet passes the switch, it closes and completes the circuit, creating a pulse of current. The control box is set to receive a preset number of pulses, switch closings, and circuit completions in a given time frame. Whenever this steady stream of pulses falls below about 70% of the set standard, that's when the control box triggers the alarm. So you see, the wiring integrity between the box and the 5 sensor switch assemblies, one for each monitored shaft, is critical. If a warning sounds, it's probably because a shaft is not turning fast enough, but it could be faulty wiring. Remember, the alarm goes on whenever the control box fails to get at least its 70% of normal pulse input. If a circuit fails, say a connector works loose, the control box won't get any pulse at all, and there goes the alarm. Let's briefly trace that wiring from the sensor end. To begin, we'll locate the 5 switch assemblies. You'll find the straw chopper assembly on the left-hand side of the chopper rotor shaft. The switch assembly is also on the left-hand side of the clean grain elevator lower auger. On the tailings elevator upper auger, you'll find the switch assembly on the left end of the auger, just above the left drive tire. The conveyor auger switch assembly is on the left-hand end of the shaft, above the front axle, and just inside the left-hand number 1 upright member. Finally, the straw walker crankshaft switch assembly is on the right-hand end of the shaft, mounted to the side sheet. The Electrical Operations Series and Test Section 240 of the Titan Series Technical Manual shows the wiring diagram and harness connections for the entire sensor system, from the 5 separate rotating shafts to the control box and to the warning buzzer. As you've seen, each sensor switch assembly has a connector called a sure seal connector. As said, a constant DC voltage of 5 volts flows through here. It may be 3 volts at the pin and 8 at the socket, or vice versa. But the voltage measured between each pin and socket will or should measure a constant 5 volts DC. Next in the technical manual, note the connector receptacles for the sensor system wiring. Each of the 5 monitored shafts has its own code number: 54 for the tailings elevator, 53 for the straw walker, and so on. But note, too, that each circuit wire has a different letter designator. For example, the straw walker circuit has 2 wires, 53E and F. This way, you can always follow the total circuit for a particular sensor by its number. And by the same token, you can always find where you are in the system, in which harness, by tracing the letter designation. Because although the number remains constant throughout the circuit, the letter will change whenever the circuit passes through a connector. Remember, go by the numbers throughout and the letters as they change, and you'll never have any trouble finding the right circuit. We'll stop the program here so you can look up the 5 separate circuits in Section 240 of your technical manual. Push the restart button when you're ready to continue the program. All right. Now we're up by the monitor control box itself. And this is the wiring diagram for the monitor control box wiring harness. Like the label says, this harness is behind the instrument panel at the operator station. It connects the intermediate harness with the monitor control box, and also connects the instrument panel warning lights with the control box. Of particular interest here, however, is this 3-contact mate and lock connector. Circuit 10K is the ground wire for the monitor system. Code 50A is the power circuit, and 56 is the circuit through which the monitor sounds the warning buzzer. However, The continuation of circuit code 56 is 43. This is an inconsistency, granted, but fortunately a rare one, yet one that can happen in such complicated wiring diagrams. This is critical, though, because this is the buzzer circuit. Be aware of this. Notice also that this buzzer circuit links up with a number of other components within the combine, which are tied to the warning buzzer. Let's look at the other wires that come out of this three-contact connector. Circuit 50, the power circuit, goes first to a 4-amp fuse, which protects the monitor from overloads. This fuse is located in the instrument panel. Remove it for inspection if the system is not working. Moving along, we next come on our circuit 50 to this electric clutch switch. This switch must be engaged for the monitor to get power. This switch gets its power through a 10-amp circuit breaker from the key switch. Now let's look at circuit 10, the monitor ground wire. Follow the wiring diagram and you see that several other components are grounded off this circuit 10. Moving along, we see that our circuit 10 goes into a 7-hole CPC with spade-type contacts. CPC stands for Circular Plastic Connector. Turn to the figure indicated, and you see that our circuit 10 goes into the engine compartment wiring harness at the hole numbered 2. And sure enough, open the engine compartment, and you will find our circuit 10 emerging from hole number 2 on the connector. And you'll also find our circuit 10 mounted to a panel screw, a ground wire for the monitor system, and several other components. We'll stop the program here so you can look up the various wiring diagrams for the monitor system. Push the restart button when you are ready to resume the program. All right? Now, suppose your customer wants to operate his combine without its straw chopper attachment. From what you know, no straw chopper will mean no rotating shaft to feed a pulsing electrical message to the control box. By the rules of the system, our guard dog monitor would bark. To correct for this, both straw chopper wire leads are grounded to this special plug on the combine frame. The monitor reacts to this by reading the ground as a closed circuit. The straw chopper light is out, and all 4 other circuits perform normally. Here are some final points to keep in mind when gauging the operation of the monitor system. First, review the wiring diagrams for each of the 5 monitored shafts. Remember that more than one harness is involved in each case, and that the diagrams will continue on to at least 2 separate pages in the technical manual. This page diagrams the monitor harness, which connects the switch assemblies, the monitor intermediate harness, the monitor control box harness, and the indicator lights and printed circuit panel. On this page are all the components in the instrument panel wiring harness: the fuse, electric clutch switch and circuit breaker, key switch, and warning buzzer. Finally, on this page, we have the engine compartment wiring diagram, which shows the component panel and ground circuit for the monitor system. Remember to follow the numbers when tracing a circuit through the system. But remember, too, that the letter designator for each circuit will change whenever the circuit passes through a connector. Remember, too, that whenever both leads of the switch circuit are grounded, the control box will not activate the warning for that circuit, as is the case when you want to operate the combine without the straw chopper. As an additional aid, you might want to see how the actual wiring for each circuit goes through the combine. Then compare that circuit to your wiring schematic. Of critical importance, remember to never
Open the monitor control box itself. That voids the warranty. Remember too that this control box is almost never at fault. When a warning light goes on and the buzzer sounds, chances are best that the shaft stopped turning or it is rotating too slowly because of a blockage or belt slippage. The low shaft speed monitoring system. It's a quick diagram. Know how it operates, and you'll be ready to handle it.